All right, taking a look at our related rates problem in number 4. A weather balloon is rising vertically at 5 meters per second. So let's say dy dt is plus 5 meters per second. But we still want to call this y. An observer is standing on the ground 300 meters away. And again, we're going to call this x. We don't want to substitute numbers too early. At what rate is the distance between the two changing? I would say this is the distance between them. There's our little guy. There's our weather balloon. Changing when the balloon is 400 meters high. So put that over here. So what is the distance? We've got to look at our distance equation, and because of the picture we've drawn, we should see Pythagorean theorem. So d squared equals, and don't substitute too early, x squared plus y squared. Now we want to talk about rates. So we've got to derive. The derivative of d squared is 2d d dt, and that's actually what we want, is d dt, equals 2x dx dt plus 2y dy dt. All right, so if we clean this up and simplify and start our substitution, I'm going to divide everything by 2, so those are just going to go away. And now I'm going to substitute. My d, if this is 300 and this is 400, my d has got to be 500 meters. So 500 d dt equals, remember I made all these ones, right? My x value is 300. My dx is what? That's the one we haven't discussed yet. It's got to be 0. This distance is not changing, so that's convenient. Plus, my y value is 400, and my dy dt was 5. So 400 times 5. And now I'm really close to finishing the problem. d dt equals 400 times 5, which would be 2,000 divided by 500. That distance should be changing at 4 meters per second. Related rates, keys, write your formula, derive, don't substitute too early, clean it up, label it correctly.